Hi everyone. Today I want to talk about factoring difference of squares, like quadratics, but better and easier. So difference of squares are special quadratics, usually two terms, and what we're talking about with perfect squares is the coefficient of the initial value or initial term and the constant are going to be perfect squares, mostly. It makes them super easy to factor because all you really need to do is take the square root of that entire expression. Let's try some examples. Example 1 here, I have 16x squared minus 9. Now, a couple things of really super importance. Number 1, the operation that links both of these terms together has got to be a minus sign. If it's a plus sign, it makes things a little bit different. So we're going to stick with minus signs for now. Second thing of importance is take a look at both of those numbers, the leading term's coefficient and the constant value. They're both perfect squares, which is again going to make this super easy. And the last thing is this. You can always identify what a difference of squares factoring problem is because this second term does not have a variable. So you can see how the variable only belongs to the initial term and there is no variable here. So all three of these things together are going to put together a really simple factoring problem. So what we're going to do is this. We're just going to actually draw one big square root sign over both of those items. Now, that's not exactly how it works, but this is the easy, surefire way to get it right. The square root of 16 is 4. Now, the square root of x squared is just x. The square root of 9 is 3. Now, here's how this works. We always want to set the first factor pair up with the perfect squares of both of these numbers, obviously, one of those variables, and a minus sign. Now, all we need to do for the second set of factors is change the sign. And we're done. Yes, we're done. I know, it's pretty easy, right? Okay, so again, take the square root of both numbers, write down both factor pairs, but switch the sign. I like to write the minus first because I don't want to have to duplicate it and make a silly mistake. Let's try number 2. Again, I'm going to draw one big square root on both sides of this or the entire thing. The square root of 49 is 7. The square root of x squared is x. Minus sign, and the square root of 25 is 5. That's my first pair of factors. My second pair of factors is exactly the same number values and variable, just with the opposite sign. And that's done. Why don't you try number 3 on your own? Okay, so if you got 2x minus 10 and 2x plus 10, you're looking good. Pretty simple process. Now, you might be wondering to yourself, how come that's so easy? What happened to the middle term? Because sometimes when we have factoring quadratics, when there is a third term up in the problem, we have to do some crazy stuff with area model and things like that. Well, if you remember from dividing complex numbers, these are actually conjugates of each other. So if you remember from dividing complex numbers, these are actually what we like to call conjugates of each other. Same exact factor pair, just a different sign. So there is a linking between these two things. Now, what happens to the middle term? Well, just like on dividing complex numbers, the conjugate eliminates, God bless you, the conjugate eliminates that middle term. So in this particular case, it would be 2x times 10, which is 20x, and negative 10 times 2x, which is negative 20x. Those two middle terms, or the second and third term, cancel completely. Hey, can you get down? Hey, get down. Thank you. So we're just left with kind of the bare minimum here. One more problem, because I think he's hungry. This one's a little weird, but it's still the same process. 1 is a perfect square. It's just 1 times 1. So this is going to be, oh my gosh, please get down. Put that back. Thank you. This is going to be 11x minus 1 and 11x plus 1. Done deal. And let's finish up. So, things to remember about this video. Number 1. Factoring difference of squares is super easy. Just remember that you're square rooting the entire thing. Now, if you don't remember your perfect squares, that's fine. Just square root the number in the calculator to get it. Number 2, the difference of squares must always begin as a minus sign, meaning your initial problem needs to always have a minus sign linking those two terms. If there's a plus sign in the beginning of that, that's going to be a whole different video's worth of information. Number 3, your answer must be both sets of factors, right? So it's going to be the minus and the plus. Just like when we talked about conjugates, I need both factor pairs with the same numbers, just a different sign linking them together. See you later.